from the Kafka consumer, the messages are sending in the Kafka producer, and the Kafka producer is going to store and uh, uh, process it through Kafka. So we have utilizing the RabbitMQ features as well as Kafka features in our presentation. We have also that if the messages are failing again and again, so we have the acknowledgement system. If the messages are failed 3 times, and we have retried it also 3 times, then all those messages which are failed are going to be in the dead letter queue, and which is going to be stored, and we can access that later. We have also multiple producer and multiple consumer type systems, so that we can make it fault tolerant and more integrated and more good. It's a basic structure of our of our solution. First, the RabbitMQ is going. We have the data in the RabbitMQ, then it's going to be in Exchange and in being processed in the queue. We have the functionality in queue that no messages are stored in the correct order. So it is going to be redefined by the Kafka. That's why we are also using the Kafka. Then RabbitMQ producer is going to produce those messages, and Kafka consumer is going to consume those messages from the Kafka producer. Then it will go in the specific topics or the names which was assigned by us, or the uh, uh, by us, and it will be stored in the Kafka clusters. So they are features of project such as parallel data transfer, batching, idempotent Kafka producer, retry mechanism, and compression. Now we have used some tech stacks, Apache Kafka, RabbitMQ, Docker for the better accessing the better Kafka and the RabbitMQ clusters, IntelliJ IDEA for coding purposes. We have also done the unit testing and integration testing to make our system more reliable and more scalable. Some advantages of our project which also we encountered, such as low latency, selective data storage. We can access RabbitMQ or Kafka whatever we want rather than using separately. We have also engaged that high throughput, fault tolerance, scalable data streaming, fusion of technologies, and also Docker container initializers, which we can see in the image. There are some references of the research papers and all some websites which we can refer, which we have referred for making our project. This is some analyze of our project throughput and the latency in respect of Kafka and RabbitMQ and integration of both of them. So thank you all. Have a good day. Any questions? We are open for the questions.
Yes, thank you for your presentation. Are there any questions?
Yeah. So Anjali, how you can define throughput as such?
Uh, uh, we have calculated it by the build success of our project.
No, how you can define throughput? Throughput as a quantity, as a variable we can see.
Can you please reframe it, like what we
For any
calculated
for
by the
any for any particular network, what how we can define throughput?
yeah, so the time we run the project in some interval of time, that's how we calculate the throughput of our project.
Because your case, your throughput is 305 bits, right, or something else.
Yes,
If you go
yes.
to your slide of that throughput, if you can please go to your slide.
Yes.
Yeah, it is through Kafka, it is 605, and through
Yes,
Pulsar it is 305. Then we have RabbitMQ, it is 38 Mbps, right?
yes.
So how you can detect the error in the data? Because throughput is basically related to the error.
Uh, okay.
Means
Uh,
whatever you are transmitting, the 100% it is not correct now. Some of the bits may get changed, some of the error may take place, so there may be some error. So how you quantify that error in your I mean these models?
we use this, I have said, like retry mechanism we have used for this error encountering, and also
Hmm.
that item prudent producer as well for these to rectify the errors and getting to know about the errors.
Okay, 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 done from my side.
Okay, are there any other questions? Okay, thank you for your presentation. It was quite informative. We can move to the next paper.
Thank you. Thank you, Ashish.
Vedic multipliers based HLR encoding. Anybody from the authors would like to present?
Yes, sir. Good morning, sir. I'd like to 1 minute.
Yes. Yes, please share your screen and your PowerPoint. Everybody each has 15 minutes.
Yes, sir. Can you see it?
Yes.
Good morning, everybody. My project is Vedic multiplier based HLR encoding. I will start with the problem statement. In traditional multiplication algorithms like Booth multiplication, they lack the speed and accuracy. So we have designed a hybrid low radix multiplier which enhance the efficiency and speed. But already in existing project, they used a Booth multiplier. This is the basic flow of Booth multiplier. Will start and left shift by last 2 bits. They will aim and they will give the output. But we use the Vedic multiplier. Yeah, this is the Vedic multiplier algorithm. Mhm. The block diagram of the Vedic multiplier. This multiplier multiplicand and we'll do the multiplier radix encoding. Partial products will be generated and using adder we'll get the final output. With this we with this accuracy will be increased and speed also will increase. Yeah. This is for example 7 into 7 will consider. This is first 7 is the multiplicand and second 7 is the multiplier. We'll encode as a radix encoding 3 bits at a time and we will generate the output. And again cross multiplication we'll get the partial products. By adding the partial products we'll get the output 49. With this algorithm speed will be increased. This is the block diagram in the RTL Vedic multiplier, and this is the half adder and full adder diagrams, encoder and compressor. This is the final output. If we queue long numbers also will get accurately and speed also will be increased. Even it will work for a short numbers also. Comparison tables. If we take two numbers, output is slightly changed. If we used HLR booth, output is 8. But in Vedic, we are getting output exactly. This reference paper, sir. Thank you. Sir, any questions?
Okay. So I have a little question. How long does your proposed method take to make the calculations, and how long does it take for others?
Sir, see, sir, here booth multiplier it is taking 6.8 nanoseconds delay.
Yes,
But our
yes.
proposed multiplier it is taking 3.5.
Yes, yeah. Because you kind of didn't refer to that table, so we didn't hear it from you. But yes, that looks quite promising.
Okay,
Are
sir.
there any are there any other questions regarding this paper? Okay, I guess not. Thank you for your presentation.
Thank you, sir.
We will move on to the next paper.
Nelanti, Sandeep, just one question from my side.
Yes, sir.
Okay, go ahead.
So you have used this CMOS, right?
Yes, sir.
So have you any idea about complementary, maybe some other architecture of CMOS as well, like for example, complementary pass transistors, CPT it is called.
Yes, sir. I have a little bit idea.
Okay, so what is the difference between the CMOS and CPL or maybe these complementary pass transistors?
Sir, I think NMOS will be, we won't use NMOS, only PMOSs will use. But in CMOS, NMOS and PMOS will use both.
Okay, 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 okay. Done from us. Okay.
Thank you, sir.
Yes, thank you for your presentation. We'll move on to the next one, which is a comparative analysis of early fusion architectures for multimodal gas detection using machine learning models. Who would like to present this?
Hi, so I'll be presenting the paper.
Yes. Please share your screen.
Yeah, sure. Yeah, I hope it's visible.
Yes, we can see.
Hello everyone, it's a pleasure to be here today. My name is Sanskriti and I am presenting a research in affiliation with Indira Gandhi Technical University for Women. This work titled Comparative Analysis of Early Fusion Architectures for Multimodal Gas Detection Using Machine Learning Models was a collaborative effort with Greeshma, Arya and Jasleen Kaur Anuja. Moving forward, let's discuss the agenda of this presentation. We'll start with the introduction, followed by dataset, and then we'll see a little bit of literature review, followed by the methodology we used, and conclude our presentation using results, conclusion, and future scope. And we'll see a little of the references that we used while backing our study. Starting with the introduction, conventional gas detection using MOS sensors suffers from limitations in sensitivity, leading to unreliable classification. This poses a challenge in safety and monitoring applications. Our research addresses this by proposing a novel multi-sensor data fusion approach. We combine data from 7 MOS sensors capturing diverse gas properties with thermal camera images. This rich data stream allows for a more comprehensive understanding of the gaseous environment. The effectiveness is evident in our model's 96.41% validation accuracy, successfully distinguishing between smoke, perfume, no gas, and the mixture. This enhanced accuracy has significant potential for real-world applications demanding reliable gas detection. Moving forward with the data set, this research paper utilizes the multimodal gas data set, which we picked from Kaggle, as a foundation for conducting experiments and generating analytical insights. The data set serves as the cornerstone of our study, enabling us to investigate various aspects related to gas detection. It consists of two modalities, a gas sensor dataset and a thermal image dataset. The gas sensor dataset comprises of three main classes of gas, as we discussed previously: perfume, smoke, mixture, and there's another called no gas, as there's no leakage. 7 metal oxide semiconductor sensors were used, and the image dataset comprises of 6,400 images. Moving forward with the literature review, while traditional gas detection methods have played a vital role, they often encounter limitations that hinder their effectiveness. These limitations include cross sensitivity, environmental variations, and limited selectivity. To address these limitations, researchers have increasingly turned to machine learning for gas classification tasks. ML models can learn patterns from sensor data, leading to more accurate gas detection compared to traditional methods. They also handle complex data and are adept at handling large datasets from various sensors, extracting valuable insights that might be missed by human analysis. Several recent studies have explored the potential of deep learning for gas detection. These studies demonstrate the promise of deep learning and analyzing complex data and achieving superior classification accuracy. The field of gas detection is not confined to traditional sensor technology. Thermal cameras offer a different perspective, capturing the spatial distribution of gases based on their thermal properties. However, differentiating between gas with similar thermal signatures can be challenging. A promising approach lies in multimodal data fusion, which integrates data from multiple sources such as MOS sensors and thermal cameras. This synergy enhances the overall performance of a gas classification by leveraging the strength of each sensor and modality. Studies by Ming and Encoding exemplify the success of multimodal fusion in gas detection tasks. Their research paves the way for further exploration of this powerful technique. As we delve deeper into the next sections, we will explore how our research builds upon these existing findings. Starting with the methodology, our research hinges on the concept of early fusion, where features extracted from multiple sensor modalities are combined before classification. To achieve effective gas classification within the framework, we employed three well-established machine learning models. First is SVM, which excels at finding the optimal hyperplane that separates data points belonging to different classes. This makes them well suited for tasks with high dimensional data like those generated by sensor fusion. Then we have random forest classifier, which leverages the power of ensemble models by combining multiple decision trees. This approach leads to robust models with improved accuracy and reduced overfitting. The last is KNN, which is a non-parametric classification algorithm that predicts the class of a new data point based on the majority vote of its k-nearest neighbors in the training data. Its simplicity and interpretability make it a valuable tool for certain classification problems like ours. By evaluating the performance of these three models on the fused sensor data, we aim to identify the most effective approach for accurate gas classification in a multimodal framework. The following sections will delve into the details of our experimental setup, data preparation, and evaluation matrix used to assess the performance of each model. Coming to data preprocessing, before feeding the sensor data into our machine learning models, we perform a series of preprocessing steps to ensure its quality and consistency. As you can see in the pictures here, first, talking about the sensor data processing flow. Fortunately, our dataset was fortunate in not having any missing or unmatching values, which we could have handled by employing appropriate techniques such as imputation or deletion. To prevent any bias introduced by vastly different scales between sensor data points, we employed a normalization and scaling technique called standard scaling. Standard scaling was chosen over other techniques like min-max scaling because it aligns better with the assumption of many machine learning algorithms, particularly those based on Euclidean distance like ours. Like we are using KNN and support vector machines. Then we reshaped our data for normalization and flattened it for downstream. For image preprocessing, images captured from the thermal images went under separate preprocessing step to prepare them for feature extraction. The images were resized to a standard dimension of 224 into 224 pixels using the OpenCV library's resize method. Normalization for training conversion was done to the data, and to achieve better training conversions, we normalize the image pixel values between 0 and 1 by dividing them by 255. By meticulously pre-processing both the sensor data and thermal images, we ensured that the data fed into our machine learning models was clean, consistent, and ready for robust feature extraction and classification. In the next slide, we'll discuss the VGG16 architecture, which we use for feature extraction of thermal images. For thermal data, VGG16, which is a CNN model, was used. This powerful model boasts a well-established architecture pre-trained on massive data sets for image classification. The benefits of pre-trained weights was that essentially the knowledge it has learned from analyzing millions of images. Remarkably, these weights encode valuable features even for new domains like gas detection, despite not being specifically trained for this purpose. The pre-processed thermal images enters VGG16 stacked convolution layers progressively extract intricate features, capturing hierarchical patterns within the image data. Max pooling layers and reduce the data size while retaining key features and controlling model complexity. The final layer before the fully connected layer, which we omitted because we wanted to extract the features, lower dimension feature maps were outputted, the essence of the image for classification purposes. Moving forward, the essence of our study, which is fusion techniques. After meticulously pre-processing the sensor data, we employed fusion techniques. We use early fusion, but we'll discuss about late fusion and early fusion both. Late fusion, each modality is pre-processed separately through its own feature extraction and classification pipeline. The outputs from these individual classifiers and then combined to make a final decision. In early fusion, which is our approach, the feature extract from both modalities are combined into a single feature vector before feeding them into a single decision-making model. This approach allows the model to learn a potential relationship between features from different modalities. Now, coming to the results. Having meticulously prepared the data, extracted features, and employed early fusion, we now delve into the heart of the research, the results and their implications. We evaluated the performance of the three learning models that are KNN, SVM, and RFC using validation accuracy, a key metric indicating the model's ability to correctly classify unseen gas samples. The results revealed a commendable performance from all three models, demonstrating the effectiveness of our approach. The random forest model emerged as a leader, achieving a remarkable validation accuracy of 96.41%. Kanan and SVM followed closely behind, both achieving an impressive accuracy of 94%. As you can see in the table, it represents the classification report for each model as well. This information includes F1 score, recall, and precision, which offers further insight into classification performance for each class. We also wanted to get more granular understanding of the classification performance. So we analyzed the confusion matrices for each model. These matrices provide detailed breakdown of true positives, false positives, true negatives, and false negatives for each class. By scrutinizing these matrices, we can identify potential areas for improvement and identify any classification errors made by the models. Moving on to the conclusion, our research has ventured into the realm of multimodal gas detection, exploring the potential of early fusions to enhance accuracy. The results are promising, to say the least. By leveraging data from both gas sensors and thermal cameras and employing effective fusion techniques, we achieved remarkable classification accuracy exceeding 94% across various machine learning models. The random forest model emerged as a champion, achieving a stellar validation accuracy of 96.41%. This is the future scope where we can do sensor suit expansion, advanced fusion techniques, real-time implementation, and gas concentration estimation, which was currently out of scope for our current study. These are some references that we use to back our study. Thank you. We are now open for questions.
So Sanskriti, the only question from my side is, like, you have applied various machine learning algorithm, right? SVM or KNN, or maybe that is random forest classifier. But it will
Yes,
be better if you apply any deep learning based approach. It will give you somewhere accuracy somewhere around 98, 99%.
yes, sir. So for that, we have papers that were using these CNN-based models, and what we wanted to use we wanted to see how machine learning models work with our this approach, right?
No,
Uh,
your aim is to evaluate the accuracy only, na?
right,
If
sir.
you
But
if you want to work only for the accuracy, then could be deep learning models would be better enough to, I mean, to approach or to apply.
yes, one of the reasons that we didn't use CNN models was because we had computational limitations.
No,
Since
your how much data you have?
it was 6400 images plus 6400
So only
image
6400 images. They can be easily applied on a deep learning model.
uh,
If suppose
there
you
are
have,
two types of
hmm,
data. Since there are two modalities, we have to process them differently, right? So using making there was a huge competition. We started with deep learning models, but it was giving a huge computational overhead.
And it was
So
also because of the data set, it was also giving us overfitting, and we found that this made it made like it gave better accuracy with less
results.
computational power.
hmm. But that would be I mean, satisfying answer. That is giving overfitting. That could be a correct answer. I mean, computational complexity is not that much with only 6400 images. Computational complexity is less, but that may be a satisfying answer. That maybe the with only 6400 images, the model may goes into overfitting.
Right, because
With
it
deep
was a
learning,
small
it
data
can
set.
be a issue. Yeah, yeah.
Yeah.
That's all. Thank you, thank you. That's all from my side.
Yes, so I have a question. Regarding your comparison, have you compared your study with other methods? Because in your table, you compare it with maybe SVM, KNN. You make comparisons with normal algorithms, but have you compared your study with, I don't know, some other people's work and try to say, set your difference with those works? As your references, you have some papers over there, for
Yeah,
example. Did
we
you
do have.
compare with that one?
Right, we do have papers, but they were so the papers that we have referred, like the paper that the data set is from, it is also using CNN but achieving the same accuracy, 96% accuracy. And with machine learning models, we found that we achieved the same accuracy for a lesser computational power, and we did not even face overfitting.
Okay, well, I mean, in the future, maybe, when you make a table, you can put your work and other people's work. So, there can be some,
Sure, sure. Yeah, like a
difference.
comparison between,
Comparison, yes. Like even if it's 0.01% difference,
right,
it should be maybe shown so that, the innovation of yours or theirs, it can be, significantly shown.
right, understood.
Okay, are there any other questions? All right, I guess not. We can move to the next paper. So the next one is called an ultra-wideband antenna with single band and dual band elimination characteristics. Who would like to present this paper?
Yeah, a very good afternoon to all of you. Naveen this side, we would like to present a paper. Let me share my screen. So paper title is that an ultra-wideband antenna with single band and dual band elimination characteristics. And authors are Dr. Manisha Kulbe, Mr. Naveen Kumar, uh, and Mr. Anubhav Chauhan. So I'm going to present that paper for this. So let me discuss what is UW actually. UW is ultra-wideband is a radio technology that can be used at very low energy levels for short range and high bandwidth communications by using a large portion of the radio spectrum. So, and another thing is that UW radio transmissions operate in the range from 3.1 gigahertz up to 10.6 gigahertz frequency. And ultra-wideband communication systems have the promise of very high bandwidth and reduced at a high level of trading for multipath and low power requirements. So this is an UWB spectrum that we can see that it lies from the 3.1 to 10.6 gigahertz frequency, in which also 802.11a, that is Wi-Fi LAN spectrum, and GPS and PCS are below the 3.1 gigahertz emitting signal strength, and it gives us a 41 dB per megahertz Bluetooth frequencies as well. So let's talk about the UW applications. So these are the major applications that can be we have used UWB, wireless communication systems and radar sensing, in which the local area network and short range radios and military communications also are the wireless communication system UWB applications. Apart from that, radar and sensing applications are vehicular radar and medical imaging and surveillance systems. We can use a UWB antennas as well. So let me discuss about the UWB advantages. It gives us a low power and good noise immunity, and the signals can be penetrate very variety of materials easily, and it gives us a high immunity to multipath fading, and potentially it gives us a very high data rates. So apart from the advantages, UWB had some disadvantages as well. The cost of the UWB antennas are quietly very high, but it gives us a slow adoption rate and low signal acquisition times. According to Federal Communications Commissions, has limited the emission requirements, which is less than zero point 0.5 megawatt maximum power of 7.5 gigahertz. So this is the one of the major disadvantages. And apart from that, the UWB technology has issues of coexistence and interference with other radio-based technologies as well. So this is our proposed antenna design, in which the parameters of the circular pitch radius and the strip pitch and the rectangular strip pitch are mentioned here. You can see. And apart from that, this is the single band notch antennas parametric analysis, in which we have created a plus design and a small circle radius as well, circle pitch radius, plus designs, and some parameters are given and with the specific photos. And this one is the final antenna design, which gives us a dual band notch antenna, in which dual elimination characteristics design, in which we have created one C shape strips and one line shape at shape sizes design. There is a 3 into 18 mm, which is designed in dual notch antennas. So this is all about the fabrication of dual band rejection antennas, in which fabrication of dual band rejection at WiMAX and LAN. The A is showing pair side antenna design, and B is showing the ground side antenna design, which is back side of the antenna design. So this is all about the testing of dual band rejection antenna after fabrication of the same. The testing of dual band rejection antenna, in which C is showing the testing with VNA, VNA testing is showing, and the measuring radiation and point camber in the rejection antenna. So these are the some observation graphs and result in which showing the antenna testing, which showing the S parameter. We can see here the S parameters lie between the 1, 2, 3, and 4. The one which gives around the -15, and 2 is showing about -7, and the 3 is showing about the 6.414 gigahertz, and 4 is showing about 10.593 gigahertz, which is a good results for rejections. And it is a VSWR antenna testing result, which is showing a good result at 5.95. And these are the some uh, differences between the UWB single band notch antennas, dual band notch antennas as well. We have created many antennas in which we have calculated the different bandwidth and notch and estrogen reflection coefficient, VSWR and gain. As we can see, the antenna is showing gain with 4.1, and an antenna F showing is 3.9 gain, and antenna C is showing a bandwidth range between 6.5 to 7.3, and same as the D is showing 6.1 to 7.1, and at the last dual band notch antenna is showing 3.4 to 4 gigahertz, which is a lie between the WiMAX band frequencies, and 4.8 to 5.9 gigahertz, which is lie between the LAN frequencies. So it is antenna I, our proposed antenna, is showing the dual band rejection antennas. Apart from that, antenna A to antenna H is showing single band notch antennas. Apart from that, single UWB antenna, which is antenna A and antenna F, is showing the whole frequency rate, which is lie between the 3.5 to 10.6 gigahertz, which is a UWB antenna range. So these are the some basic observation we have calculated and we have observed, in which parabolic structure in antenna I is we have used substrate. This is FR4, and WiMAX LAN is rejections found in antenna I. That is same as previous, and from antenna B to antenna H, we have also used a substrate FR4, but in parabolic design we have used epoxy substrate. So antenna B to antenna H is also showing the WiMAX antenna rejections. So these are the basic about the antenna A and antenna F parametric designs and substrate yields and rejections. So talk about the conclusion and future scope of the proposed antenna is in this paper, a compact parabolic monopole antenna is presented and designed over a partial ground plane. The structure is low cost planar wideband UWB antenna with band rejection can work in 4 modes, that is full UWB, individual WiMAX or LAN rejection, or satellite X-band rejection. And antenna I, which is dual rejection, which is showing a WiMAX and LAN rejections as well. For the full operating band work from the 3.5 to 14.2 gigahertz. The antenna is a low cost FR4 substrate and has been tested for band rejections, which are found about 16 and 10 dB in WiMAX and LAN bands. So we talk about the future scope of this. We can analyzing this design for triple band and multiple band for notch antennas in wider applications. So we have used some references that is mentioned here, and these are the some other details. Dr. Manisha Kulbe, and this is me, Naveen Kumar, and this is Mr. Anubhav Chauhan. Thank you from my side. Open for the questions.
Yes, thank you for your presentation. Are there any questions?
Yes.
Okay, so I can ask one. What type of devices do you plan on implementing your antenna in, since you have made this contribution?
Okay, sir. Sir, because we have created many antennas, you can see here
Yes,
in
okay.
this. So we can use for particular range bandwidth, so, such as we have designed antenna which is ranges from the 3.4 gigahertz to 4 gigahertz. As we can see, the nowadays particular WiMAX antenna bandwidth rejections is devices are manufactured and planned to used, but we have created dual band rejection antennas in which we have uh, used for multi-purpose as well, for WiMAX and WAM as well. There are many devices such as which are working for 4 band rejections. For particular, that may be high cost, but for particular band rejections, we can use for these WiMAX and WAM rejections. It can also be used in medical equipments as well to recognize some tests and other things as well.
Okay, thank you very much.
Thank you.
So, if there is no other questions, we can move on to the next paper. So, well, just a second, let me find. Yes. So the next paper is design of an efficient bio-inspired spatial multi-criteria analysis framework for evaluating the impact of transportation projects on the environmental conditions. There's only one author, if they are here. Bach, I guess. Your microphone is off, I guess. Your microphone is not working.
Hello. Hello.
Yes, now we can hear you.
Hello.
Hello, we can hear you.
Yes. I can.
Yes, please start from the beginning.
Okay. I am Saurabh Bhattacharya, research fellow, Department of Computer Application, National Institute of Technology, Raipur, Chhattisgarh. My topic is design of an efficient bio-inspired spatial multi-criteria analysis framework for evaluating the impact of transportation project on the environmental conditions. So I will like to cover.
Your microphone is right now gone. It's not giving any sound. You suddenly cut off. Can you hear us?
Yes, sir. I can hear you.
Now you came back. Okay, your microphone is working again. Please carry on.
Okay. So, in a formal introduction, I can give you the transportation infrastructure projects have a significant environmental impact, including habitat loss, noise pollution, air and water pollution over there. So there are many challenges. Conventional approaches to evaluating environmental effects are time consuming and lack of multi-criteria approaches over there. So I'm proposing a novel net framework SMCA is suggested for assessing
Your microphone is again down. We can't hear you.
hello.
Yes, we hear you now. Carry on.
Okay. Uh, we will discuss about applications of SMCA framework. This applied various transportation planning scenarios, including urban transportation, airport development, and road and railways planning over there. Benefits of SMCA framework, where the SMCA framework can be applied in various, the proposed where offers several advantages over the conventional methods over there. So practicality and efficiency, the SMCA framework provides a practical and effective means of assessing environmental impact of transportation projects over there. Sorry. So we will review of existing methods. We're evaluating the terms over there. There are various techniques which are used, like we can have the EIA, which is cost benefit analysis, that is CBA, where multi-criteria analysis, MCA, where life cycle assessment over there, and sustainability assessments. The proposed spatial multi-criteria analysis framework offers several advantages over current technique. It provides a comprehensive evaluation of transportation projects by considering environmental impacts and employing three multi-criteria decision-making techniques. The SMCA framework is efficient, effective, and adaptable to different project scenarios, making it valuable tool for decision-making and planner in transportation infrastructure development. So proposed design of effective spatial multi-criteria analysis framework for evaluating the impact of transportation project on the environmental conditions, where we can have this kind of design over there, which we can make it various things we can efficient of a current model used to assess the environmental effect of transport project is often limited by a small number of analytical parameters and scalability issue, so hindering their real-time applicability. In contrast, the proposed model incorporates three multi-criteria decision-making methods, that is BioAHT, TOPSIS, and TOPSIS with the fuzzy weights, and TOPSIS to enable a more comprehensive evaluation, where we have seen in the diagram itself. So, transportation projects can yield both positive and negative environmental impact, necessitating a thorough evaluation process. Some parameters which we can consider it over there for the air quality, where we can consider where assessing pollutants like carbon monoxide, nitrogen oxide, and particulates to gauge air quality impact by vehicle emission, where another thing which we can have is an air quality over there, which evaluating the factors such as pollutant level, sediment concentration, and presence of heavy metal to assess water quality effect by runoff and erosion. Where noise pollution can also make a major decibel levels and noise frequency to evaluate the noise pollution arising from increased traffic over there. Habitat loss is gauging habitat loss due to ecosystem fragmentation, wildlife disturbance, and natural habitat destruction. We have this habitat loss over there. Land use change, where evaluating changes in the landscape and the ecosystem fragmentation resulting from transportation project. Socio-economic effects can also be assessing impact on the community displacement, traffic congestion, and property values. Climate change is one of the considerations, where the CO2 emission, carbon sequestration potential, and climate change effect on infrastructure also. Energy consumption is another point where we can have the evaluating energy used during project construction and operations and renewable energy availability over there. Safety, we need assessing the accident frequently, severity and associated risk can also be there, which we can calculate it. Visual impact, where evaluating the aesthetic and visual intrusion on the landscape itself. Culture heritage, with assessing impact on historical sites and cultural landscape, which we can consider. Ecosystem services, while evaluating impact on ecosystem like carbon sequencing and water purification, which need to be considered over there. By considering these parameters, the proposed model offer a comprehensive approach to assessing transportation project impact on the environment, enabling informed decision making and better management of environment effect. Where we have the comparative results over there, where we can see the technique for order of preference, where compared to the proposed framework incorporates 3 multi-criteria decision-making technique, namely technique in order of preference, technique for order of preference by similarity to ideal solution, that is TOPSIS, and analytic hierarchy process, that is AHP, and TOPSIS with the fuzzy weights, which we are using. The framework is designed to accommodate both quantitative and qualitative criteria, which is supported by an Ant-Loyan optimizer, that is ALO, allowing for a more comprehensive evaluating transportation projects. To evaluate performance and proposed model, it was tested on the various data sets and samples to take the consideration over there. So these are some results we got into, where our proposed model is more better than already there in this. Sorry. So we have a conclusion there. We're saying the study proposed a novel model aimed at improving the speed of accuracy and identifying environmental effects associated with the transportation projects by combining optimization techniques such as ALO, AHP, TOPSIS, and fuzzy TOPSIS, where the model identifies optimal parameters and feature sets for various transportational scenarios over there. So we have the future scope where we can say the future research could explore incorporating additional data sources like satellite imagery and real-time sensors data to enhance precision and broaden the model scope to include the wider range of environmental effects. So continuing research and development are needed to refine and expand the proposed model for a more comprehensive and effective approach to assessing environmental effects of transportation projects. That's all from my side. Thank you very much. You have a question.
So Saurabh, only one question from my side. As you are taking the data from satellite images, right?
Yeah, yes, sir. It's the future. We are planning for that.
Okay, so you are taking this various data set as such. So
Yes.
maybe you have think of, because different images are being taken at different point of time when the position of
Yes.
sun could be different. So have you
Yes.
think out for any kind of atmospheric correction to be done?
So we are studying on various parameters now on. I'm working on it, and various things I have not imagined over there, but you are saying your suggestion is very good. I can think on it. So I have not taken that considered over there.
Yes, because what had happened, if we are taking images of satellite, then maybe the position of sun will be different, maybe the illumination will be different.
Yes.
So every time when we take the image, it will be having a different kind of illumination to be exposed. So we
Yes.
need to apply
Yes.
some sort of correction to the data so that we can have all the images to be onto the same scale.
Yes, sir. Yes. Yes.
So maybe when you are applying such criteria, you have to take into consider this particular point.
Oh, yes.
Yeah, yeah. Thank you.
Thank you. Thank you very much.
Yes, very good suggestion. In fact, different satellites can have different type of cameras. Their calibrations can be different, so their noise can also be different. They need to be also thought about. But could you please open up one of your last graphical presentations where you had some graph comparing with other methods?
Yes.
Exactly. This one or that one, doesn't matter. Yes. Over here, what is x-axis? What is y-axis? Could you please explain? We didn't understand what the x and the y-axis is.
one second. In this, I forgot to make it since 1 minute. I also taken into. Uh, Sir, it takes the performance on the basis of the x-axis. We are taking it as the sorry. Uh, Sir, y-axis we are taken as a percentage, which we can take into account. Sir, x-axis we are taken as the impact of
The impact or the number of projects, the x-axis.
yes.
So y-axis, if the project's accuracy is maximum 100, there is no need for 120%, I guess.
Yes.
So,
Yes.
after 100, there is nothing to compare with because 100 is the best. It is super accurate or whatever. So above that, you don't need to present it or put a line over there. Okay. I
Yeah.
think this graphic can be refined and some X and Y titles can be placed to make it more
Yes.
clear. Are there any other questions? Okay, I guess not. So we can move on to the
Thank you very
next.
much.
Thank you for your presentation. We can move on to the next paper. So we are right now on the potential of emerging sensor technologies like LiDAR for enhanced spatial computation, unlocking the future of technology. Are there any authors who would like to present this?
Yes, me and my co-author Preetipal would like to present. I'll be sharing
Yes.
my screen now.
Please share your screen.
A very good afternoon to respectable chair members. Today, my name is Preetipal and I'm currently pursuing BTech in Electronic and Communication Engineering from Indira Gandhi Delhi Technical University for Women. And my co-author Soumya Sharma is doing the same. Today, we both will be presenting a presentation on our research paper called Potential of Emerging Sensor Technologies LiDAR for Enhanced Spatial Computing. The flow of this presentation will be like, first of all, we'll discuss the problem statement, then we'll review the literature, further we'll provide an introduction, and there is a case study that we have presented in our research paper, which is regarding the Apple Vision Pro. We will be discussing that. And moving on, we'll be giving, and for this presentation, we have developed an interactive model for visualizing LiDAR more easily. So we'll be presenting that as well. And then we'll be giving future outcomes, references, and the bibliography is present. So moving on to the problem statement, what we aimed for this research paper was we wanted to study the comprehensive analysis, the impact of light detection and ranging technology, which is LiDAR, on spatial computing. Also, we explored the multifaceted application of LiDAR. We evaluated its benefit. We examined the transformative influence what LiDAR will be having on a digital landscape. Additionally, in the paper, we have presented, as I mentioned before, a case study on Apple Vision Pro. So we wanted to show how that spatial awareness in user experiences is now becoming a reality for us. And we have developed, as mentioned before, a LiDAR visualization model. And through this analysis, we basically aimed to like eliminate the potential of LiDAR as an integral component of the future spatial technology and advancement. Moving on. Uh,
we have a review of literature. We took the inspiration from some of the research paper that were present, and this basically tells us what they are presenting and how our views are different from them as well. And further to the introduction.
Okay, so I will be introducing. Um, let's start with the explanation of LiDAR. So LiDAR is short for Light Detection and Ranging. LiDAR is a cutting-edge remote sensing method that uses laser pulses to create highly detailed 3D representations of the environment. By emitting these lasers at precise intervals and recording the time that it takes for them to reflect back, LiDAR measures the distances with a remarkable accuracy. At the core of LiDAR tech is the time of flight principle, which is basically involves firing rapid laser beams that bounces off surfaces and returns back to the sensor. The elapsed time from emission to return allows the system to calculate the precise distances. But LiDAR isn't just about measuring the distance. By analyzing characteristics like light intensity and wavelength and advanced systems, it can differentiate between various object types also. This capability enriches the data that is collected and enabling not just 3D mapping of our images, but also a comprehensive understanding of the scanned environment. LiDAR can basically broadly be divided into three main types, which is the terrestrial LiDAR, which is commonly utilized for high precision surveying of mapping of smaller areas. This is something that we have based our visualization model on later. Airborne LiDAR is another type, which is mounted on aircraft or drones for capturing large-scale maps of vast areas. And mobile LiDAR is integrated into vehicles for real-time data acquisition and is often used for autonomous navigation and infrastructure mapping. So the LiDAR's application, this is a brief uh, text for LiDAR's application. LiDAR's applications are vast and varied and stretched along many fields, including environmental mapping, where it plays a crucial role in creating accurate and detailed map of natural landscapes, facilitating tasks such as monitoring deforestation, assessing landslide risks, and analyzing ecosystem health. Autonomous navigation: in the realm of self-driving vehicles, LiDAR provides critical real-time data on surrounding objects with high precision, enabling vehicles to navigate their environments safely and efficiently. In case of urban planning, urban planners rely on LiDAR to create accurate city models. This technology helps in assessing potential development sites and optimizing the infrastructure design. Archaeology is another department. Here, LiDAR can help archaeologists to discover structures hidden under dense vegetation or buried very deep beneath the Earth's surface, revealing insights into ancient civilizations without need for very invasive techniques. Lastly, agriculture. And in agriculture, LiDAR data aids in optimizing crop yields, managing resources efficiently, and monitoring the health of crops, paving the way for precision in agriculture as well.
So now that we have understood what LiDAR is, we need to know how LiDAR can be implemented. So to implement it, there can be various components used based on its application, but four of the main are, first of all, is a laser source. As my co-author mentioned, LiDAR works on time of flight, theory. So laser source is basically, it emits short pulse of light and with the wavelength that is chosen based on the specific application of the LiDAR that we are using. Secondly is the scanner. Scanner then precisely directs the laser beam across the desired area and it scans the mechanism often utilizes in rotating mirrors or galvanometers for control movements. Furthermore is a detector, which basically the reflected light is captured by highly sensitive detectors and which converts the light signals to an electrical signals, which then is taken by the data acquisition system and it calculates the distance and object properties that's stored in the acquired data for further analysis. Now, co-LiDAR was like one of the first development of LiDARs, which further got like in the coming years, it become more advanced. So now modern LiDAR units are basically used in most of the applications. Then when seamlessly integrated with spatial computing, what LiDAR does is it bridges the physical and digital worlds, and it unlocks the potential of creative, immersive, interactive, and context-aware digital experiences. Then spatial computing, we need to know what spatial computing is first. So spatial computing basically represents a technological paradigm where computers are not just limited to interacting with digital realm, but also are capable of understanding and manipulating the 3D space around us. So AR VR is one of the greatest example of spatial computing that we can come up with. Then LiDAR basically captures the data instantaneously, and it proves such scenarios. It basically helps in such scenarios. We used to in the past we used camera based sensors, but we don't use those these days. We rather use LiDAR, which basically give you the real time information of the surroundings. Further we move, so the spatial computing is not basically confined to the static environment. It can be used in autonomous vehicles for giving us the real-time understanding of the surrounding for safe and efficient navigation. Also, study conducted by National Oceanic and Atmospheric Administration have demonstrated that LiDAR can achieve like centimeter level accuracy in the ideal condition. And the symbiotic relationship between LiDAR and spatial computing basically gives us the mutual benefits of both the worlds. As both the technologies used evolve, we can expect more groundbreaking advancement in the various fields. Now, the Apple Vision Pro is the case study that we have presented in our paper. Apple Vision Pro is all the rage right now, and it basically represents a bold stride towards the future of human and computer interaction. And it is like one of the physical example that can be given of a LiDAR and a spatial computing, a symbiotic relationship. So Apple Vision Pro transit this limitation by offering a wearable augmented reality experience. This innovative device have cutting edge technology like high resolution micro OLED displays, powerful processing capabilities, and crucial sensors, as we mentioned before, LiDAR, which fundamentally transform how users interact with information and navigate to their physical surroundings. In the devices like Apple Vision Pro, spatial computing works hard, like hand in hand to create an immersive mixed reality experiences. Also, by analyzing the properties of reflected light, LiDAR empowers Apple Vision Pro to distinguish between various objects in the environment. This device serves as a testament to the transformative potential of spatial computing, and we can expect further advancement in this field to unlock a world of exciting possibilities and reshaping our relationship with technology and the environment it inhabits. Further, moving to the visualization model.
Yes, so this is a interactive LiDAR visualization model. This innovative tool transforms complex LiDAR data into an intuitive 3D point cloud. Such visualizations are invaluable across various fields such as urban planning, environmental science, and civil engineering, as mentioned before. The model allows users to visually interact, explore geographical areas with unmatched precision. So by providing detailed visuals of terrain and infrastructure, this model aids in landscape assessment, feature detection, project planning. It basically turns raw data into a clear, actionable format that can help professionals to make informed decisions and strategic plans. So when we started with collecting data, and we used the USGS Earth Explorer to collect the LiDAR data, where we can find the .las or .laz files, which are the LiDAR files. We can basically select the LiDAR point cloud folder, and within it LiDAR AOI, and we can select a particular area which we want to map using the LiDAR data. So the LiDAR data of that particular area is already present on the USGS Earth Explorer. We basically download that data into .las or LAZ files, and then we can use it to upload it in our model, which would create the point cloud image for our LiDAR data. So and this visualization model uses Python as a powerful programming tool for data handling and visualization. The key libraries that are used are LASPy for reading the LiDAR files, NumPy for efficient data manipulation, and Open3D for creating interactive 3D visualizations. Okay, so one of the quick steps, what we basically did was we loaded the data
read the LiDAR data from the LAZ files that we downloaded, extracted the X, Y, and Z coordinates of each point, and then visualized it using the Open3D library to convert the point data into a 3D point cloud, enabling our users to visually inspect the model interactively. There were several steps in the Python code as mentioned, and the outcome was basically by color was separated by different colors, and these colors are typically used to represent different evaluation levels in a point cloud, elevation levels in a point cloud. This is a common approach to use a gradient from cool to warm colors. And as we can see in the next slide, this is how a particular piece of land for which we selected the LiDAR data, and the topography is represented using different colors, and the warmer the colors are, the more highly elevated that topography of land is. So this visual representation not only aids in understanding the terrain and surface features more comprehensively, but also enhances the accuracy of geographical analysis and planning. So the future outcomes that we can expect, or what we have concluded from this research, is that in the future you will see advanced LiDAR sensors, which will be next generation of the sensors and will boast higher resolution and faster scanning rates, which enable more precise and detailed 3D mapping and object recognition. Not only that, we can expect the integration of AI and machine learning more into the LiDAR. This fusion with the LiDAR data algorithm will unlock a new level of understanding of the physical environment, and this could lead the development of contextually aware spatial computing applications. And we can also expect the improved accessibility of LiDAR technology, as these days it can be a little difficult to access the LiDAR technology, but in the future you can expect it to see like everywhere. So improved accessibility, what do we mean by that? It becomes more miniaturized and cost effective, and we can expect a wider integration into smartphones, wearables, and other consumer electronics. Now, India is just starting out with LiDAR and spatial computing right now, but it has a real chance to be world's leader in the field if India encourages people to be like more into innovation field and help group work together and create helpful rules. It can really benefit from these technologies and influence how spatial computing develops around world. And to maintain this trajectory, what India can do is like education and research. They can like invest in that for LiDAR purpose. Then public private partnership again for LiDAR. Then government initiative and support. Government can further support India's ascent in this field. Further future scope is something that we have come up with, which is what we can expect in the healthcare sector. And one of the key benefits that we can see is the respiratory monitoring system. So what LiDAR can do is it can be utilized to non-invasively monitor the chest and abdomen movement of the patient in real time, and it can provide continuous data on respiratory rates, rhythm, and depth. And how it would work it, first of all, LiDAR can be used to like real-time 3D map of the patient's chest and abdomen, which then used with advanced algorithm can help us to identify patterns indicating specific respiratory disorders like asthma. Further, the data from LiDAR can be integrated into another monitoring system, giving us patient health status. And then it can do remote monitoring, as LiDAR is portable, so it can be adopted in home settings and allowing remote monitoring of the patients. Also, as it is no contact technology, so we can expect not no risk of transmitting infections. Further, these are the references that we have used for our paper and the presentation. And the last slide is of bibliography that we have used. We are now over. Thank you, and we are now open for the questions.
Yes, are there any questions regarding this paper? If you just come back to a few of your slides in the future work section. Yes, right over here. This graph presents the, I think so, LiDAR market size in India. In 2029, suddenly it goes to $1.4 billion, I guess. But the, what do you call it? The increment is very linear, but suddenly in 2029 it increases two times. Why is it all of a sudden? All those years it's
Actually,
been nicely progressively, but suddenly in 2029 it goes incredibly high.
Uh, so the reason being, as we have already seen the hike in these technologies with Apple Vision Pro, like not many people knew about LiDAR or spatial computing much, but as soon as Apple Vision Pro launched, people tried to like learn what technology goes behind it, how it is working. So now, as people are getting more aware of this technology, we can expect the hike, of course, but if the this is on supposed basis that government will be taking more initiative, and the development phase will be a few years. Once that
Mhm.
development phase is done, we can expect a great hike in this market. Because like
Yes,
then we have a build up technology and everything, we just need to integrate it, and then we can work it for any model. And
yes,
especially we can expect it in the forest purposes, like because lidar can show you like in the depth in the forest as well. It cannot be like breaking from the trees, or it can we can like it can give you in-depth sensor, in-depth map, 3D mapping of an area. So like you can expect it in various sectors. It will grow with a great hike. That is
yes.
how we can
I was
actually
just
see.
expecting a more gradual increase rather
Yeah.
than, it's like this and then suddenly it's like that. It doesn't seem very organic. That's what I was trying to say. But
Yeah, yeah, yes,
I'm sure
but
it
we
will
can
increase much more, even maybe more
hmm.
than that over
Yeah,
time.
even like by involving this drone technology and all these kind of stuff, maybe it really supports the development of such lidar based technologies also.
Yes, sir.
Exactly, exactly. Okay, thank you very much for your presentation. We can move on to the next one, which is evaluating the impacts of climate change on the environment using bio-inspired spatial multi-criteria analysis. Mr. Tushar is going to be presenting.
Tushar, are you there? I
In the
think he's
list.
not there.
Yes, he's not in the list currently in the attendees. I can't
Yeah,
see his name. Then we will move on. If he comes back, we can,
yeah,
invite him to
yeah,
present again. The next one is review paper on attendance management system using facial recognition. Any of the authors here of this paper?
Yes, hello everyone. I'm Samiksha Bharti and I'll be presenting this review paper.
Okay, please share your screen.
Yeah, sure. I hope my screen is visible.
Yes, we can see your screen.
Yeah. So, good afternoon, everyone. The topic of our paper is
so
we
Samiksha,
are,
your institute name is not there. Which particular institute you belongs to?
uh, sir, the institute name is IGDTW, Indira Gandhi Delhi Technical
Okay, okay, okay,
University
okay,
for
okay,
Women. Yes.
okay.
Okay. So the topic is a review paper. We are reviewing uh, the system, that is attendance management system using facial recognition. I have three more authors, that is Neha Singh, Sejal Singh, and Ekta Saini. The table of content is as follows. First, we will see the problem statement, then the description of the technology, that is facial recognition technology, and then we will review the algorithms and see the comparison chart, and after that we will see their future scope. So the problem statement is, that is, despite advancement in facial recognition technology, the deployment of facial recognition based attendance system faces challenges in achieving consistent accuracy, efficiency, and usability across various real world scenarios. These challenges include and just not limited to lighting sensitivity, privacy concern, scalability, variations in facial angles and features, and the need for continuous algorithm is required. So the facial recognition technology description is goes as follows. It utilizes biometric principles to identify individuals based on facial features. So the steps that are involved in recognizing the face. First step is to capture the image. The second one is to detect the face and then feature extraction and then the database matching for the particular image and then the person identification. So in face detection step, the first step is detecting a face within a larger image or scene. This process involves distinguishing facial features from the surrounding environment and pinpointing their location within the frame. And in the face face detection face analysis step, once a face is detected, the technology analyzes the facial features, and this analysis is typically based on the geometry of the face, measuring various key points on the face known as landmarks or nodal points, which can include the distance between the eyes, the shape of the jawline, and the contours of the cheekbones, lips, and nose. And in the feature extraction step, the analysis results in the extraction of facial feature, which are used to create a face print or face template, a digital map of the face geometry. And lastly, in the database matching, this face template is then compared against a database of known faces. This is done using sophisticated matching algorithms that can handle variations in lighting, facial expression, and angles. And finally, the face of the person is identified and the attendance is marked in the system. We have reviewed these four algorithms. The first one is HAR ADA boost, and next is the LBP ADA boost. The third one is Euler Jones, and the last one is SVM, that is support vector machine. So I'll be going deep into each of the algorithm one by one. The first one is HAR ADA-boost. The HAR classifier or a HAR cascade classifier is a machine learning object detection program that identifies objects in an image or video. So the algorithm can be explained in four stages. The first is calculating HAR features, and in this step we collect HAR features. A HAR feature is essentially calculations that are performed on adjacent rectangular regions at a specific location in a detection window. The calculation involves summing the pixel intensities in each region and calculating the differences between the sums. So here are some examples of HAR features. These are the edge features, and these are the line features, and the last one is the four rectangle features. The next step in this algorithm is creating integral images. So without going too much into the mathematics behind it, integral images essentially speed up the calculations of these HAR images, HAR features basically. Instead of computing at every pixel, it instead creates sub rectangles and creates array references for each of those sub rectangles. and these are then used to compute the Har features. And the third step in this algorithm is using AdaBoost. So firstly, I would explain what is AdaBoost. AdaBoost is a machine learning algorithm which makes a stronger classification algorithm using the output of weighted classification algorithms, which are known as weak learner. A weak learner is defined the way that it can only be better than random, or in other words, is closer to the right orientation. And in contrast, strong classifiers refers to a set of classification algorithms that are highly correlated with the correct orientation, and thus it can change the poor learners to minimize the errors in subjects not classified. This way, many of the images that do not belong to the human faces will be deleted, and more calculations will be done on the frames that have more chances to be in the face. And in contrary to other methods, AdaBoost chooses the characteristic that will provide more predictability. A very high percentage of these frames in an image are those that contain no faces. AdaBoost essentially chooses the best features and trains the classifier to use them. It uses the combination of, as I mentioned, about the weak classifiers to create a strong classifier that the algorithm can use to detect objects. Weak learners are created by moving a window over the input image and computing hard features for each subsection of the image. This difference is compared to a learned threshold that separates non-objects from objects, and because these are weak classifiers, a large number of Har features is needed for accuracy to form a strong classifier. The last step is to combine weak learners into a strong learner using cascading classifiers. So finally, we are implementing cascading classifiers. The cascade classifier is made up of a series of stages where each stage is a collection of weak learners. Weak learners are trained using boosting, which allows for a highly accurate classifier from the mean prediction of all weak learners. And based on this prediction, the classifier either decides to indicate an object was found that is positive, or move on to the next region, and we consider this as negative. Stages are designed to reject negative samples as fast as possible because a major of the windows do not contain anything of interest. It's important to maximize a low false negative rate because classifying an object as a non-object will severely impair our object detection algorithm. We So the next algorithm that I would like to explain here is the LBP AdaBoost. The LBP stands for Local Binary Pattern, and it has many applications such as image recovery, remote assessment, medical image analysis, face image analysis, motion analysis, and environment modeling. For each pixel in the image, binary code by thresholding the pixel value in relation to the central pixel value is determined, and finally a histogram is created to collect the various binary patterns. Here is an example that illustrate this algorithm. LBP is faster but less accurate. If we want to detect faces on an embedded system, it is the default choice, and because it does its calculation in integers. If we compare this with the first algorithm, that is Har AdaBoost, the Har uses floats for processing, which have poorer support on embedded and mobile processors. As a result, the performance penalty is significant. big enough to make its usage on mobile phones impractical. And the third algorithm that we have reviewed is the Euler-Jones. Euler-Jones algorithm is also a machine learning technique for object detection proposed in 2001 by Paul Euler and Michael Jones in their paper Rapid Object Detection using a boosted cascade of simple features. The algorithm was primarily conceived for face detection, despite it has lower accuracy than modern face detection methods based on convolutional neural network. The Euler-Jones algorithm is still an efficient solution for resource-constrained devices. And the last algorithm is the SVM support vector machine. The support vector machine or SVM is one of the most popular supervised learning algorithm which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning, and the goal of this algorithm is to create the baseline or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future, and this best decision boundary is called a hyperplane. Lastly, our we have summarized all these algorithm in form of a chart by comparing the algorithm against its accuracies. The Har-Adabos has the maximum accuracy rate, and the Waller-Jones has this come on the second position in terms of accuracy, and the SVM is the least accurate algorithm that is being used in facial detection algorithms. The future scope of our work is that is integration of manufactured insights and profound learning methods, utilization of 3D facial acknowledgement, innovation, integration of cloud computing may empower more versatile and adaptable participation arrangements, and advancements of more capable and cost-effective sensors may assist in improving the capabilities of confront acknowledgement and acknowledgement frameworks. Thank you everyone for listening, and now open for the question.
Yes. Are there any questions regarding this paper? Okay, I guess not. Well, this was one of our last papers, but before we end this session, let's ask again, is Tushar here? Because Tushar was not here earlier.
So
Maybe.
Samiksha, there is a one question from my side.
Yes, sir.
Yeah. So you have compared various algorithm as such, but I think I haven't find any state-of-the-art algorithm in your comparison. Means those who are being using nowadays as such. Means Har-Babel it is quite old, and you are using Euler-Jones again it is quite old. What is the state-of-the-art algorithm as such? Means which are being using nowadays as such. Have you think about like, and this is one thing, and second thing that I would like to ask, like as you are saying that it is an attendance system. So
Yes, sir.
suppose that I am sitting at my home and just scan my face, so my attendance get recorded.
No, sir, it's not like that. Your attendance will be done if while
Hmm.
sitting at your place. You have to come, and the machine needs to is installed there, and over there your face will be scanned, and then your attendance will be marked.
Means that you are saying that there will be a standalone machine in the college itself.
Yes,
Okay. So, I mean, if the machine is being connected over there and you have to see your face in the machine itself. Okay. So, but
yes,
again,
sir.
The camera will do the same thing. Why we need such kind of machines as such? Maybe we can build the same function in the camera itself. Means actually, what I want, the student should get comfortable out of it, and we should, avoid the proxies as such. So we should give this particular function to their mobile phone. Then only the purpose of like getting a facial recognition based attendance could be solved. So everybody can come up with their mobile phone and they can give their attendance through their mobile phone itself. So there could be a better idea to have the attendance as such.
But sir, if we are doing that with the phone, then won't it be that they'll not come to the college itself, na? Like if the application is there in their phone, they can get the
No, no.
at
What I should say, like for example, we could have a common Wi-Fi. Means if the person's mobile is going to be connected to that particular Wi-Fi only, then only the attendance is going to be registered. And to connect that particular Wi-Fi, student has to come down to college. That
yes,
could,
we can look into
that
that.
could be
Yes,
a
you are
better
correct.
idea.
Yes, yes.
As per my thinking out of your project, whatever you are presenting. Okay, then that's all from my side. Thank you. Thank you.
Okay, thank you,
Okay,
sir. Thank you.
thank you. I guess one of those authors is not here again. Tushar is not going to be able to present, so therefore, this is the end of the session. Thank you for participating, and thank you for my other co-host, Dr. Abhishek. Thank
Yeah,
you
thank you.
for
Thank you. Thank you,
attending.
Hakan. Thank you.
Thank you.
Is Ashish here? No. Thank you all for presenting your work. Good luck in your academic studies later on in the future.
Thank you, sir. Thank you.
Thank you so much to the respected session chairs and all the paper presenters. That was it for technical session 7. We will meet for technical session 8 at 2:30 after lunch. Thank you so much.
Okay.
Thank
Thank
you.
you. Thank you.
Take care, everybody.
Yeah.